All right, so this is my molar volume box. Hopefully this number looks somewhat familiar. 22.4 liters is what we call the molar volume at STP. So that means if we're at standard temperature and pressure, this is the standard temperature, right? 273 Kelvin or 0 Celsius. Standard pressure is 760 millimeters of mercury, or if we're in ATM, it's 1 ATM, right? If we're in kPAs, then it's 101.3 kPAs, but this is the standard pressure. So that means if I have a gas, and it doesn't matter what gas, it can be any of these gases, O2, N2, CO2, hydrogen, like in our lab. If I'm at this temperature and this pressure, I know I'm going to have that volume. And that's it. And it becomes a very helpful way to calculate things, just like molar mass is. Okay, these are the molar masses for these three gases we get from the periodic table, right? They tell us the relationship between grams and mole if we're trying to weigh things. This tells us the same relationship, but it's a relationship between liters and moles, okay? Our molar volume, which means, do you know how many molecules of hydrogen gas would be in this volume of 22.4 liters? Since it's a molar volume, hopefully you realize that, yeah, it's Avogadro's number of molecules in a mole. So that all becomes something that ties together now. All right, we've said a mole is the link, the heart of chemistry, right? Because it's a certain number of molecules that, for a gas at least, has this volume when we're at this temperature and pressure. And it has our molar mass in weight. So all of that becomes linked and connected together. And so that's a pretty important concept, especially when we use chemical reactions that produce gases, that links that all together.